Hi, and welcome to video 3 for section 1.2. In this section, we're going to be giving you a brief introduction to scientific notation. So by definition, scientific notation is a positive number x is said to be in scientific notation if it is expressed as follows. So that number x is another number a times 10 to the nth power. And we have a couple criteria here. First, a is greater than or equal to 1 and less than 10. And n is an integer. And n is positive if the number is greater than 1. And n is negative, so it's a negative exponent if the number, we're talking about this large positive number or small positive number, if it's less than 1. So because it's positive, it's still going to be greater than 0, but it might be, so a lot of times this is used in like your science classes, biology, physics, chemistry. If we're talking about the size of cells, they're very, very little. So we don't want to write all the decimal with all the zeros after that, so we can use scientific notation. Or if we're talking about maybe the distance from the Earth to the Sun, you wouldn't want to sit there and write out all the zeros, so we can use scientific notation, and it's just a shorthand. Some examples real quick here. Let's say we have 4 times 10 to the 5th power. So what this means, what this value is equal to, is 4, and if we think of like a decimal point here, right after the 4, we have to move it 5 units to the right. So 5 is positive, so that means we're moving to the right. So if I had a decimal here, 1, 2, 3, 4, 5, it would end up at this point, so I have to fill in zeros the rest of the way. So 4 times 10 to the 5th really means 4 plus 5 zeros, which would be what? 400,000. So instead of having to write it out, because otherwise that's where we run into errors. Maybe there's 12 zeros. And if we only write 11 zeros, that's going to be a big issue in terms of calculation or describing what we're talking about. Going the other way, let's say we have 4 times 10 to the minus 5th power. So this would be something very, very small because of the negative here on the exponent. It doesn't mean the number is negative, it just means that that's the direction we're having to move the decimal point. So now, because it's negative, it means when I start filling in zeros, I have to go to the left. So again, assuming that the decimal is right after the 4, I need to move 5 places. 1, 2, 3, 4, 5. So my decimal now moves to here. I'm going to put a 0 in front just as like a placeholder, or as a indication that this is a decimal and it's not like a stray mark on the board, just a period there on your paper or whatever. So again, we need to fill in zeros the rest of the way. So it should be 4 with 4 zeros after the decimal point. And that's what 4 times 10 to the 5th power means. Going the other way, what if we're given these numbers, but we want to write them in scientific notation? So the first one, let's say we want to write in scientific notation 56920. All right, well, the first thing we need to do, if we look at what the form needs to be, is we have to have the a value here as some number between 1 and 10, which means what? It means that in order for that to happen, my decimal is going to have to go here, 5 point something. So that's what's going to give me a number between 1 and 10. So in scientific notation, it's going to be this guy, 5.692. Now, why don't I write this 0? Well, the whole point of scientific notation is what? Is to get rid of all the zeros if there are any. And so up here, I didn't write 40000 because that's what scientific notation is doing. So here, if I'm changing a number to scientific notation, if there's a 0 at the end, I don't include it in my value for A. And then it's what? Times 10. Well, this number is bigger than 1, so I know it's going to have a positive exponent. And how many places did I have to move? Well, the decimal was here to start. I moved what? 1, 2, 3, 4 places. So because I had to move 4 places over, that means it's going to be 5.692 times 10 to the 4th. That's how I would write this number in scientific notation. And then lastly, what if I have 0.0000, so 4 zeros, 9, 3. And I want to write this in scientific notation. Well, again, I have to start with some number that's between 1 and 10. So in this case, that's going to be, if the decimal is here, 9.3. So it's going to be 9.3 times 10. Well, this number is obviously much smaller than 1, so we know it's going to have a negative exponent. And up here, you don't have to necessarily write the positive. I just wrote it for you guys to indicate that it was a number bigger than 1, so our exponent was going to be positive. Obviously, with a negative exponent, you do have to write it. So then the question is, how many spaces do I have to move from where it originally is to in between the 9 and 3? And what do we get? 1, 2, 3, 4, 5. I have to move 5 places to get the decimal between the 9 and the 3, which means my answer is going to be 9.3 times 10 to the minus 5th power. And that's really it. So we can add, we can subtract, we can multiply scientific numbers, numbers in scientific notation. Once we do that, it's just a matter of multiplying those or adding the A values and taking into account what my scientific number, my 10 to what powers are. So that's it. That wraps up video 3. Pretty short video. Again, just kind of a introduction or a reminder, maybe if you've already been doing scientific notation in previous classes. When we have a number written in scientific notation, what number does that actually indicate? So come on back. We'll look at video 4, and that'll be the last of the videos for section 2.